I don't know about you, but I really like physics. I like space. And so here we have the SpaceX Starship test landing. I'm just going to zoom through the thing. And so the basic idea was this is a super large rocket that can possibly go to the moon, possibly go to Mars, and it can land and stuff like that. So what you're seeing here is a test of the upper stage. I think it's just in 2 stages. And it launched, and then it's landing on the ground, and it failed. But overall, I think it did a fairly nice job. I mean, it's a really large rocket, and it went up into the sky, and it came back down. I mean, I think that's incredible. So, but I want to do the following. Look at this landing. It's landing right there, and so the question is, it was coming too fast, apparently. So what is the acceleration during this landing? That's what I want to find out. Okay, so just for fun. So I have a clip of this video. I'm going to use tracker video analysis, and we're going to get a plot of the vertical position as a function of time for this and find the acceleration. And I haven't done this already, so we're doing this live. We'll do it live. So first of all, this is tracker. If you go to, I don't have the address right there. If you just Google tracker video analysis, I'll put a link down below. This is a free, very detailed, very great video analysis program. It does use Java. It runs in Windows. It runs in Mac OS X, Mac OS 10, Linux. So it's been around for a long time. It's a great tool. It does take a little getting used to, but I'm going to use that. So let's just jump right into it. I have Tracker already opened. I need to get my file in there. So once you get the video downloaded, which I'm not going to tell you how to do because I'm not allowed to, but I'm sure you can figure that out. So I'm going to load in my clip. And I'm going to go through the whole process here. Everything that you need to do, I'm going to do, including loading. And if you want a joke, I could tell you a joke. But, I mean, I really do I think it's fun to do video analysis. Some people ask me, well, would you use this in a class? And I don't normally have students do this in class because it's very tedious. If you want students to do video analysis, personally, I like Pivot Interactives. They have really great videos. I'll put a link there down below too. So let's just expand this window, make it bigger. Right? Why not take up the full size, right? Okay. Now the first thing I want to do is there's parts of this video I just don't need. I only want to look at the landing, and you'll notice that if I actually grab this little, I can change the parameters of the video by dragging this little slider right there, and that just says where the video starts. You could also go up here to the video properties setting, and you can say what frame you want to start on. You could also change the frame rate. Okay, so this one says it's 30 frames per second, which I assume is real. But if it's in slow motion, you might have to change that. Now, see right here, I cannot analyze the motion of this because there's nothing in the background to determine how the spacecraft is moving. So I need to get something that I can use as a reference. Right here. See right there. I can use this. Now, that's not actually in the same plane as the rocket, but if the camera is far enough away, I think this is going to work. So let's start right here. Now, when I mark an object on the screen, I get the time values and the pixel values, right? So I get the X and Y pixel values, but I really want to correlate that with a time, with a distance. So I need to do a couple things. I'm going to need to set the scale of the video, and I'm going to need to set the axis of the video because the camera is panning and moving as the rocket goes down. So let's first start with the coordinate system. Up here, this button, if I click that, it'll put an axis on here, and I can move this to wherever I want. I want to put it somewhere where I'm going to be able to determine where that is. I'm going to put it right at the corner of that thing, which I know is not going to be perfect because I'm zooming in. Because there's an explosion, and so it's going to block it. So let's just go back to, let's say 200% zoom. That looks good. Okay, now the other thing I want to do is, okay, I'm going to go up here and say, what do I want to do with this coordinate system? Do I want the origin fixed, and do I want the scale fixed? The angle is going to be fixed. I don't think the camera rotates. I don't actually know. I think that it does not zoom in. So let's just put unfixed. There's other ways to move the coordinate system too, but in this case, it seems like a fairly simple motion to do. So now I need to say how big is stuff in here. And the most obvious choice is to use the rocket itself. So let's go back over here to, this is the SpaceX page on the Starship. And you can see that it says the height of the Starship, the second stage, is 50 meters. So I don't know if that's true, but that's what I'm going to use. Just here's a picture of the whole thing. That's 120 meters. But this test just launched this top part up here. Let's see, what are the other pictures? I think I messed that up. Okay, go back. I didn't. Okay, that's good. Let's go back over here. So 50 meters. So I'm going to go over here to this option and click New Calibration Stick. So this is how I calibrate the video. So now I just want to shift click, and you notice when I hit the shift button, my mouse changes. I'm going to click at the top of the rocket and at the bottom of the rocket. And there's a stick right there, and it says it guessed. I can move it if I want. It says 174 meters, but I want to click that and type 50 meters. Return. Okay, now I've calibrated everything. So really, I'm pretty much done. Oh no, I'm not done. I want to zoom out. Let's zoom out. Let's do 100%. And now I want to go through. I don't have too many frames here. I'm going to go through and move my coordinate system every time the frame moves. And then I can go back and mark the rocket. So I'm just going to step through this. And you see here, the coordinate system changed. So let's change this to 200% so I can see a little bit better. I don't really care about the rocket. I just care about my coordinate system. So that moved. Tedious, right? Well, you know what? Lots of things in life are tedious, and you just have to do them. But you know, I kind of enjoy. There's other ways to do this. There is an auto tracker that can track things automatically. If it's a short video, I just find I'd rather do it myself and have complete control. And this doesn't have to be perfect. I'm not a version of video analysis. I'd be okay with that. I'm not Bob Ross. Okay, so this does get a little tedious. But I really don't have too much to go. As soon as I see that explosion, I can... And you'll notice I'm looking at the size of this little structure right there. And it does not look like it's changing. So I'm going to make the assumption that the camera does not zoom. If the camera did zoom, I'd have to rescale in each frame. And actually, if you did that, you'd want to use a different method. There's a method in here called calibration point pairs, which really you take 2 points in the frame, in the video frame, and mark them. And you know the scale between those 2 points, and then you just remark those 2 points, and it moves the coordinate system to adjust so that those 2 points stay the same place. And you can see here my smoke is from the rockets getting closer, so I know I'm getting closer. Well, I still got a ways to go, but that's fine. You don't mind, right? I find people don't mind longer videos. So I wish I had some questions to answer right here, because that'd be a great thing to do. How did you get into video analysis? Huh. Okay, so I will answer that question. I think my graduate advisor, when I was a grad student, he did video analysis. And so he made this program called, there were a couple earlier ones. I can't remember the name of it. Videograph. He made a program called Videograph that did the same thing. It wasn't... I can't remember. There was another Videograph, but it was a little bit better than Videograph, but not as good as this. And then Tracker Video came out, which is free. I started doing video analysis when I started blogging. I started doing it a lot more, which was, I think I did, there's this commercial for a Ford truck. I think it was Ford. The truck comes out the back of a cargo plane as it's landing and on the runway, and the truck uses its own brakes to stop the plane. And I think I did a video analysis of the speedometer, well, not the speedometer, whatever that's called in a plane, to see how fast it was slowing down, which is kind of a weird way to do a video analysis. I did a lot of early video analysis on, Angry Birds. I was a huge Angry Birds fan, and so I would record the gameplay and then use video analysis to get position and time data from that. But, I like to look for movie trailers because I get excited about Star Wars or superhero stuff, and if they have a good scene that I could get some data from, then I'll try to do that. And those are much tougher because they're typically going to have cameras that pan and zoom to make a better effect, and so it's a lot more work to get the data out of there, but kind of enjoy the challenge. Okay, we're almost there, because once this thing explodes, I can't see the background anymore, and so I'll just stop. But I think I'll have enough to get it. You can see there the rocket's really close. And maybe if I wanted to make a shorter video, I could have just pre-moved this or edit this video to make this part quick. That's what I should have done. But maybe next time. Unless you guys like this. There's another, I also like doing an analysis of YouTube videos because there's a lot of videos that say, oh, is that real or fake? And I like to get data from the video to kind of get an estimation if they are real or fake using physics. One of the things that you would always look for is the acceleration of a free-falling object. If the acceleration is negative 9.8 meters per second squared, then that's good. If it's not that on Earth, then it could be fake. So that's a very good thing. Another very fun thing to look at in fake videos, and it's harder now, but it's what they'll do is they'll take a video camera and record a scene with a tripod, and then they will add like a fake shake to make it look like the camera's being handheld. What they do that for is so that they can add their effects on a stable video frame and then undo that stable thing by adding fake shake. But I have detected the background motion of different videos, and you can see that it's definitely not real shaking. It's very regular based. That was one of my favorites. I don't think they make those terrible fake videos anymore with the shaking. They have better ways of making fake shake, probably because of my video analysis of the situation. I like to believe might not actually be true. Okay, it's almost landed. It's going to blow up. See, but right now I'm already losing my thing. I think I might just stop right here because that smoke's really covering up. And this looks like it just zoomed in. Let's zoom out real quick and see if the size of the rocket. If it is, I think I'm gonna be in big trouble. So this should still be 50 meters. I think be careful, don't slide that bottom thing. I'm just gonna slide that top one. It doesn't want to slide. And you'll notice that the coordinate system moves. Okay, there. I think I'm at the beginning. No, get to the beginning. Okay, there. Well, it's kind of slide. I think because I'm recording and using a Java program, things are just kind of like, eh. Okay, now I'm going to go to create point mass. And I just made a point mass. It's going to give me the option. I give it a label and a color and all that stuff. I don't really care. I'm just going to call it mass A. And I need to pick a point on the rocket to mark. I'm going to use the top of the rocket. So all I have to do is shift click and click the top of the rocket in each frame, and then it'll move to the next frame. And then that's all I need to do. Let's zoom in so that we can see it better. Now, this won't tell me the orientation of the rocket because I'm treating it as a point mass. But if you wanted to get that, you could use the bottom point. So I click that, and it advanced a frame. It's supposed to. Let's see, I'm on 338. 339. Okay, now it's doing it. So I just need to hold down the shift key and click on the nose of that. And you don't have to be perfect. Just make a happy point. That's my... But this goes a lot faster. All I have to do is click. The program is running slow, and I think it's because I'm recording. And you'll notice that I'm not really moving my mouse too much because the camera is following the rocket. But the coordinate system, this point relative to the coordinate system of this coordinate, I can change that to the y, which I will in just a second. And I can't remember how many frames I had. I'm really not doing anything at all, just clicking in the same spot, holding down the shift key. Now sometimes if you might need to move the point a little bit if it's in the exact same location as it was before. Sometimes it wants to select that other point, but it looks like it's working right now. And I'm going to get some variation in the point because there is some error associated with both my location of the coordinate system and the location of the point. But the more data you get, the better it gets, and it's not that big of a deal. So, and this is the part where if it was any longer, I would use auto tracker. So auto tracker uses visual detection of a point. And so this would work because it's very distinguished. There's a high contrast between the rocket and the background, so the computer could figure it out. But it's really not that much points. I'd rather just click each one. I think I should be close to being there. Let's see. I can't remember which. I should have ended the frame, but I did not. I did not. Okay. Let's do a couple more points. Oops. Right there. 1, 2, 3. That's 3. Okay, I think that's good enough. Let's go over here. Now, what I want to do is get the vertical position. So this is horizontal position as a function of time, which actually is pretty cool, right? It is moving horizontally, and we can find the velocity of that. Let's go ahead and do that. No, I want to do the vertical acceleration. I said I was going to do that first. So you can plot all sorts of things up here. You can do the velocity, but I'm going to do the vertical position. And I'm going to go down here to analyze, and it will open it in a new window. Hopefully. There it goes. So you can see here that it doesn't even look like it's accelerating. Let's go ahead and fit a vertical line to this, a linear line. So I'm going to go to curve fit, and I'm going to say line. And right here it says it already fit it. It's a really great fit. This says that the equation of the line is y equals at plus b. And since this is position versus time, the slope of this line is the vertical velocity. So a is it's actually 34 meters per second. That's actually pretty fast, right? That's fairly fast. Okay, let's find the acceleration though, because I think over here it does look like there's a slight acceleration. I'm just going to highlight this part of the video data, and I'm going to go change this to a quadratic, a parabola, and fit it. Okay, so that fits fairly well, and you'll notice here that I have a t squared plus b t plus c, so there's a is negative 4.5. That's accelerating down? Huh. That's strange. So this is, I actually put up a graph right here. I've made an equation for you. So this is the equation of object with the constant acceleration. So the term in front of the t squared is 1/2 the acceleration. So if you multiply those together, going back over here, my acceleration would be -9. That doesn't seem right. Maybe it is indeed falling. Okay, let's highlight the whole thing. And now I have a smaller negative acceleration, but that says it's speeding up. I'm really kind of surprised right there. It's speeding up going down. Okay, let's do this. Let's go over here to the velocity, the y velocity. And let's see what this looks like. Okay, now this case, it actually showed my previous graph too. I have y and vy, so I can just uncheck these. says that it is indeed going fairly fast down, but accelerating. So I don't know if that's legitimate or not, but that would definitely... I feel like it's not. I feel like I've made a mistake somewhere. But this says that it accelerates as it goes down. Let's just go over here to the video. Let's just see if we can see. See, and I'm looking at the video right here, and is it zooming in? I don't think it is zooming in. But this says it's like speeding up as it goes down. And going fairly fast. So, now, I'm just thinking here. I could take this video up here and look at the angular size of things on the ground, and if I know the field of view here, I could actually use that to get a distance from the camera to the ground and use that to find the acceleration. I'm not going to do that. That's your homework. But seeing if that gives me the same thing here, but it looks like maybe that's what happened. Maybe it didn't have enough thrust to slow it down. And accelerated on the way down, and it sort of, maybe it's right. Okay, well, I think I will end there. So I will post a couple of links. I'll post a link to that video that I used. I'll post a link to Tracker video analysis. I thought there was, and Pivot Interactives is really great too. I'll post a link to that. So go ahead and play with this if you want. It's really fun. You can find some cool things. If I'm right about the acceleration of this, that would be amazing. But let me know. I'll talk to you later.